Hello, I wanted to talk about a subject that some of my students have difficulty with, and that is dealing with negative numbers in addition and subtraction problems. So I wanted to talk about this in a couple of different ways. One of them is on a number line, and one of them is using algebra tiles. So how do we represent a number using algebra tiles? And this is actually fairly easy. You just simply use the number of algebra tiles to represent the number you're trying to represent. So if I've got 3, then I use 3 algebra tiles. If I've got 4, 4 algebra tiles, and so on and so forth. So what about on a number line? Well, on a number line, we use two different representations. One, we can just simply go to the number we want to represent. If I want to represent the number 3, then I find that position on the number line, and I see the 3 there, so that is the number 3. Another way of doing it is to draw an arrow going from 0 to 3, and then using a or drawing the point in the direction of movement along the number line, because we always start at 0. 0 is our starting point, at least for addition and subtraction. And so then I can label this number 3, and so this arrow represents the value 3. I can then move this arrow around. So let's say I wanted to add 3 to 3, and so there's two ways to represent that. I can take this arrow and I can move it, I can copy it and put the arrows tip to tip like this, like so, or not tip to tip, but one on the end of the other, and we can see that it brings me to the number 6. Or, instead of copying the arrow, I just simply put the base of the arrow, the starting point of the arrow, the end of the arrow here, at the number 3, and then I move along the number line the amount, or in the direction of the arrow to get to the value 6. So those are the two different ways of representing values and a quick addition on the number line. So how do we talk about adding negative values then? Well, we can sort of draw an arrow in the same sort of direction as we did before, going from 0 to negative 3, and it points to the left to represent negative 3. So we've got negative 3 here. And if we wanted to add negative 3 to negative 3, then I can do the exact same thing. Move this arrow so that its end is starting at negative 3, and then we see that we're at negative 6. Or, again, I can copy this arrow so that the tip of the arrow matches the end of the previous, or it goes from 0 to 3, and then the next arrow comes right on after that, so that at the end of it is at the tip there. And so that would be adding and subtracting, adding two positive numbers or two negative numbers. If we're representing negative values with algebra tiles, then I use a number of algebra tiles to represent my value, like so, right? Using red algebra tiles instead of blue ones. Now these algebra tiles are two-sided, so if I needed to flip them over for any reason, which we'll talk about in a little bit, then when I flip them over, they go from red to blue, or blue back to red. Okay. So, the next thing I wanted to talk about is, how do I add and subtract negative values? Well, if we think about movement along the number line as one step forward and then one step back, then that would be equal to 0, because I would just end up back on 0. Well, what is one step forward and one step back? Well, that is adding 1 and subtracting 1. And so if we look at our algebra tiles, each blue algebra tile represents a positive one, and each red algebra tile equals a negative one. So if I'm adding numbers, then I add them like so. Let's say I have 5 blue tiles and 3 red tiles. Then if I want to add these numbers together, then I would grab pairs of numbers, this blue and this red, and I would match them together. So when I've paired my positive and negative tiles together, they're going to cancel each other out, and I'll be left with 2 positive tiles together. So that was 5 plus negative 3. Notice how this is very similar to how we would treat positive 5 and minus 3. So if I wanted to take positive 5 and I want to subtract 3, then the way we normally think about that is by grabbing these 3 and taking them away. And after they're taken away, we're left with 2. So both of these problems give us 2. And so adding a negative value is the same as subtracting a positive value. Now, what about subtracting negative values? Because we already know that adding a positive value, right? If I were to do 5 plus 3, that's going to equal 8, right? And then how do I get that? Well, I take my 5, and then I take my 3. And 5 plus 3 is 8 when I squish those two groups together. So what about 5 minus negative 3? What is that going to equal? Well, if we see the pattern over here, it's highly not highly recommended. It's highly likely that this is going to be 8. Now, the reason that this is true is if we look at my 5 and 3 as above, I want to remind everyone that these tiles here are two-sided, that we flip our algebra tiles over when necessary. And when we subtract, right, if I'm subtracting 3, then I can also do this operation here, right? If I do 5 and 3 represented this way, then subtracting a value is the same as flipping those numbers over. So in this case, when I'm taking this negative 3, I want to flip the values over, and they turn into red values. And when I'm subtracting a negative 3, then I do the same thing. I flip them over and they become positive tiles. And so 5 minus 3 is equal to 2 when we've canceled out the pairs that match up. But when we are subtracting negative 3, then those negative 3 turn over to become positive 3, and we add them together to get 8. And so adding a negative value is the same as subtracting a positive value, and subtracting a negative value is the same as adding a positive value. So how do we represent this on a number line? Well, if I'm starting at 5 for all of these cases, then let's add our positive and negative 3 lines on here. So this one is our negative 3, and this one is our positive 3. And then we draw the arrows at the ends of them. Negative 3 here, positive 3 here. Now, if I'm adding a value, then I just simply take my arrows and I move them into position, right? Adding 3 means I put the bases of each of my numbers at each of my arrows at the number I want to start at, and then I move along the arrow to reach 8, or in this case, if I'm adding negative 3, to reach 2. Now, what does subtracting a number on a number line look like? Well, there's two ways of thinking about it. You can either flip the arrow around so that it points in the opposite direction, Or the representation that I think I like better is to actually just put that number or that arrow so that its tip is now at the position that you're starting at. So in this case, I would take my arrows like this, where their tips are pointing at 5, and I move along the arrow backwards. So to subtract 3, I move along the arrow backwards, going from 5 down to 2. But if I'm subtracting -3, then again I put the tip of the arrow at 5 and move backwards along the arrow to subtract, and I end up at +8. And so we've talked about how to add and subtract values using algebra tiles and the number line, and we get the same type of result either way. Now, one other thing to talk about is that when we are dealing with two values of the same type, two positive values, right, a 5 and a 3, and then when we subtract a -3 it turns into a positive value, then positive and positive is always going to give you a positive result. And the values stack on top of each other. So this is addition. If I'm adding two negative values together, right, a negative and a negative, right, or I'm taking a negative value and I'm subtracting an amount, right, then what happens is that, say in this instance here, right, where I've got -5 and I'm subtracting 3, well then that means all of these blue tiles here turn into red tiles, right? And this is also the same as adding -3, right? I could add -3, or I could just simply subtract +3, and the result is that I'm going to have the 3 negative tiles here. And that isn't 2, that is -8. So when I'm adding two negative values together, I have two negative values, I'm going to get a negative result because I'm still adding. It's when I take a positive value and a negative value that I'm going to get subtraction. Notice +5 and -3 gives me 2, and so that is subtraction. And this is the same as if I did -3 and +5 equals 2, because this would just simply be the other way around. Using the same tiles, the same group is going to cancel out. We just simply flip the order here of my number, or my tiles. So these, I put them over here, and then move them that way. Adding, you just squish them together, and tiles that are the same are going to cancel each other out. And so we end up with subtraction, right? And so in this case, we had more positive value than we had negative value, and we ended up with a positive result. Well, if we had the exact same situation, but instead we had -3 and we're adding 5 to that, right? -3 plus, or -5 plus 3, well, we're going to end up getting -2, right? The result here is that these 3 here are positive values, and so we get the same type of cancellation effect. These 3 negatives and these 3 positive are going to cancel each other out. I'm going to be left with 2 negative tiles. And so if I have more negative than I have positive, that's going to equal a negative result. This would be the same as if I took 3 and I subtracted 5. I'm going to get -2 because this 3 is positive, this 5 is negative. I'm subtracting a positive value, which means it's a negative number. If we think about it in terms of flipping those positive values over, and we're going to get -2. And again, it's the same sort of effect as I had up here, but all of my values here are going to be blue tiles, and then all of these ones are going to be red tiles. And again, these 3 and those 3 are going to cancel out, and I'll be left with 2 negative ones. Alright, I hope these representations make sense and that they're helpful for understanding the interactions between positive and negative numbers, and positive and negative numbers when we're adding and subtracting our values. And I hope you have a good day. If you have any questions or other topics you'd like me to cover, make sure to put those down in the comments below.